All right, hey everybody, Miss Knoll here. I promised you some notes by me. So here are the notes, similar to the Khan Academy video you should have watched on Wednesday. It's on evaluating and then really just properties of graphing polynomials. You'll have Desmos, or if you have the TI-84 app that I wrote in the Google Classroom post, you could do it on TI-84 as well. But I will be using Desmos in this video. But let's first start off talking about just general properties of polynomials. So a polynomial is a function of the form f of x equals an times x sub n plus blah, 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 all the way to a0. So really, I say the blah, 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 because everything in the middle doesn't really matter much. All of the power in these functions, polynomial functions, comes from the first term. And then the last term is important because it'll tell us the y-intercept always, which is nice. So it's a good thing to have when we're looking at polynomial properties. So polynomial functions of the form this, the leading term, the front term, and the last term are the most important. And here are some definitions. So the first term gives the degree and the leading coefficient. So the degree of a polynomial is the highest exponent, and that should always be in the front. So right here is your degree. So this would be degree n, whatever number that would be. The leading coefficient is also with that first term, which has the most power. That's a sub n here, but whatever number is there is going to be the leading coefficient. We kind of know from quadratics that this has a lot of power because if it's positive, with quadratics, we knew it opened up, and if it was negative, it reflected. That same property is going to hold here with that first leading coefficient, so it's very important. And then the last thing that's important is the constant, and that's the number at the end that doesn't have a variable. If there's no constant, that means that number is 0. And what's great about that for polynomials, it's always the y-intercept. So the first term and the last term have a lot of power when describing properties of a polynomial function. And then last thing, my first definition here, to be in standard form, just like quadratics had to be ax squared first, then bx, and then c, the constant. To be in standard form for a polynomial, it has to be the term with the highest exponent, and then the next highest exponent, and the next blah, 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 until the constant. So in decreasing order of exponents. And I'll show that as I go through these examples next. So if you look at this green box here, common polynomial functions, constant and linear, we're kind of done with those, even quadratic, but notice quadratic, standard form. There's the ax squared, bx, they just use a different letter here, and then c is the constant. If it's a cubic polynomial, meaning your highest exponent is a 3, the first term of that polynomial should be x cubed, and then x squared, and then x, and then the constant. If it's missing some of those terms, that's fine as long as they're in order from biggest to smallest, whether or not you skip some over. And then again with the quartic here, a quartic has degree 4, meaning the highest exponent starts with a 4th, and then you have every subsequent one thereafter until the constant at the end. And again, even if you're missing terms, just look at this quartic example. It starts with a 4th, so this function doesn't have a cube and a square, but the next highest is an x, and then the last is a constant. So it's important to note, to be in standard form, a polynomial has to go from highest exponent to smallest exponent. And again, where the highest exponent, that term in the very front, has the most power, and the term at the very back, the constant, also has a little power because that's the y-intercept. And if you want to make that note, sorry, I'm using my fingers here, so it's hard for me to write, but that number in the back is the y-intercept. And then the term in the front, the leading coefficient, just remember, if this is negative, it reflects. So a negative reflects. I'll put it in parentheses. If it's a negative number, it's a reflection. Otherwise, it looks like the parent. And we'll see this as we go through a few examples. I'll make sure to mention whether or not it's reflected or not. But that A is very important. The N is very important because it shows the shape. And then the constant at the end is also very important because it shows the y-intercept. All right, let's look at some examples of polynomials. And first we'll decide if it is a polynomial or not. Then we'll put it in standard form and we will find the degree and the leading coefficient. Not so concerned about type, although I think it was mentioned in the Khan Academy. So I have a little side note I'm going to put up here on the right. So to be a polynomial function, a few things must be met. First, all exponents must be positive integers. Meaning numbers 0, so exponents have to be 0, 1, 2, 3, so on. No negative exponents. A negative exponent, we'll find in a little bit, in a couple lessons, flips the variable into the denominator, and that's bad. So to be a polynomial, all exponents must be positive integers, and all coefficients, meaning the numbers in front, must be real. So no i's. So we won't see any of those imaginary numbers here in coefficients. So if I look at these examples, example 1, or example A, I have this function h of x equals x to the fourth minus 1/4 x squared plus 3. Well, let's look at my exponents first. All exponents have positive integers. So 4, check, that's good. 2, that's positive integer, check. 3, even though you don't see it, it's x to the 0, so that's good, check. And then I look at my coefficients. So the coefficient of x to the fourth is a 1. That's not imaginary. Negative 1/4, not imaginary. 3, not imaginary. So we know this is a polynomial. We'll just say yes, because I'm writing with my fingers. But yes, it is a polynomial. And then it says, if so, write it in standard form. Well, standard form means you go from the highest exponent to the smallest. So let's look at it. Start as x to the fourth, and then it went to an x squared. And then I went to my constant, so it already is in standard form. So to save a little time, I'm going to put a check. It's in standard form. And then the degree, I switch my colors here, is the highest exponent. So the degree of this polynomial is 4. Just because I'm writing with my fingertip, I'll just color code. So the degree is 4. And then we're not so concerned with type right now, so let's cross that out. That's a quartic is the type because the highest exponent is a 4. But we're more concerned now with the leading coefficient. And the leading coefficient is the number in front of that first term, and that's a 1. So why that's important when we get to graphing in a couple minutes is that means this quartic is going to open up. It'll really look something like, if I were to graph it, it would kind of look like a quadratic but have something going on in the middle. Let me go to the next one. So if you look at example B, I look at my terms and I want to see are all exponents positive integers. So here this is x to the first, that's good. This doesn't have an x, that means it's x to the 0, that's good. X squared, good. So all of these for requirement 1, all exponents are positive integers. Now let's look at requirement 2. All coefficients must be real numbers. So 7, that's real. Negative root 3, that's real. It's weird, but it's real. Pi, even weirder, but it's still real. So this is a polynomial. We won't see many like this. Is it in standard form? This one is not. So to be in standard form, the highest exponent has to come first. So this term, pi x squared, should come first. I'm sorry about my handwriting with my fingertip here, but pi x squared must come first. The next highest exponent is the 7x. There's no sign there, so we just assume it's positive. And then the last term is minus square root of 3. And then next, the degree, what's the highest exponent? Well, now that it's in standard form, that highest exponent's a 2, so it's quadratic. The lead coefficient, as weird as it is here, is pi. And that's positive, so you kind of should know, even though it's pi, it's going to open up. So you know that quadratic's going to look something like that. Let's just look at the next two quickly. They're both not polynomials. Let's see why. So in example C, I check all exponents must be positive integers or 0. So this one's good. This one is not good. So x to the negative 1, that's not a positive integer, so no, this is not a polynomial. Now if I look at my next one, I got x to the first, that's good. 2 to the x, that exponent's not even a number, it's a variable. So this is also not a polynomial. So that's how you determine whether or not you're a polynomial, and then also the degree and leading coefficient. All right, let's look at evaluating polynomials. There are two ways to evaluate. Because of what's going on right now, we're just going to focus on one, direct substitution. And that literally means what it sounds like. If you're given an x value, we're going to directly substitute that into the polynomial. And if you're lucky, you have a nice graphing calculator. If you're not, you're going to have to do it step by step. So here I say I have an example. Use direct substitution to evaluate this polynomial when x equals 3. So literally, wherever I see an x in the polynomial, I'm now going to put a 3. So I'll go ahead and write this with blanks where the x's are. And I'm going to use my TI-84, my Wabbit, and I'll post those instructions here as well in case you didn't get it in the beginning of the year. And if for some reason you can't download it, I may be able to somehow get you in touch with Mr. Pons to figure out why. Or there's an app on your iPhone, I think called TI. I looked it up. Let me look at it real quick. I downloaded it. Maybe I didn't. I think it was TI-84 or 84 Connect. Well, anyway, you can find a calculator on there. Let me look. TI. I'll look for it and I'll send it again. But it's an app that looks just like a graphing calculator that we use in class. So anyway, I'm going to use that here. So when I plug in f of 3, I'm going to put 3 into all these x's. And I'm just going to jump to my calculator and go ahead and type that in. And if you have the Wabbit on your calculator, feel free to do this. If you don't, again, I think it's TI Connect or 84 Connect, Connect 84, something like that. But it's just like a TI-84. And I'm just going to type this in just the way it looks. So 2 times 3 to the 4th minus 5 times 3 to the 3rd minus 4 times 3 plus 8. And then I get 23 as an answer. So that function value at 3 is 23. And that's so easy. I'm not going to bother doing this second example, but I mean, it works the same. You just take this -2 and you put it in for all these x's. And then plug it in a calculator, or even do it step by step. You can figure it out. And then you get the value of the function when x is whatever they tell you to find it at.